We looked at quadratics, parabolas, and one of the types of questions was find the zeros, the roots, the solutions, or the x-intercepts, which all mean the same thing, of the following quadratics with these factors. And remember, quadratic is something that has x squared as the highest power. So if something's already factored, we can say, all right, what makes this equal 0? And so we can split it up. We have x minus 2, what makes that equal 0? And many of you can do this in your head, but if not, you just solve. So we would add 2 to each side. And so one of the zeros is at x equals 2. The other 0, we have x plus 9 equals 0. We can subtract 9 from each side. And the other 0 is at x equals negative 9. So if we were to graph that, it would look something like this. Well, not like that. Let's see here. So at 2, there would be a 0. At negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So not drawn to scale. But at negative 9 and at 2, your parabola would cross the x-axis. Now for the other one, it's not factored. And so we have to figure out what two things multiply to x squared minus 13x plus 36. This is when we used our box and circle to factor. So with our box and circle, we put our x squared in the first box, our negative 13x in our middle circle, and our 36 in the last. So we want to know what multiplies to the first and the last box, multiplies to 36x squared. That adds to the middle circle, negative 13x. All right, so what multiplies to 36? That would be 9 and 4. And if we make them negative, they'll add to negative 13. So again, 9 and 4, they multiply to 36. They add a negative 13 if we make a negative. All right, let's get the outside of the box. So it multiplies to x squared. We have x and x. X times negative 9 equals negative 9x. X times negative 4 equals negative 4x. So the two factors of this would be x minus 9 and x minus 4. Okay, so those are the factors. I should write factors. But it says find the zeros. So again, we're going to use zero product property. We're going to set it equal to 0. What makes each of these 0? And there's two answers. One will be 9 and one will be 4. So these are the zeros where they cross the x-axis. We also learned in this chapter how to build the equation from the graph. So if you have the graph, how can you go backwards and get the equation? So the first step is to find your x-intercepts. So where do they cross? It looks like at negative 1 and 3. So let's write that. X equals negative 1, x equals 3. Let's write them as factors. Factors are the opposite of the zeros. So we have x plus 1, x minus 3. Let's find a point to plug in. And so here's the y-intercept is at 0, negative 3. This is an x and a y value. We're going to plug in the y-intercept and solve for a. So here's our equation. Y equals an a value, which makes our graph wider or more narrow. And we have our factors, x plus 1, x minus 3. We're going to plug in for x and y. So wherever I see a y, I'm going to put a negative 3. We don't know what a is, so we're going to leave that a. And then we have 0 plus 1, and we have 0 minus 3. All right, so when we do that, we're going to solve. We'll have negative 3 equals a. And then we have 0 plus 1 is 1. 0 minus 3 is negative 3. And then, I'm going to show my work up here, we get negative 3 equals a times negative 3. Again, we're solving for a here, so we're going to divide each side by negative 3. So we have 1 equals a. And then we're going to rewrite the equation. So to rewrite the equation, we have y equals, and then a is 1, so I'll just leave that a 1. And we have x plus 1, x minus 3. Now since a is 1, you don't have to write the 1 right there, but you can. So again, the steps are find the x-intercepts, write them as factors, find the y-intercept, plug in, and then solve for a, rewrite your equation. So that's how you can build the equation of the quadratic. All right, other things that we learned in this chapter. Quadratic formula. If you can't factor, so if you can't use the box and circle to find the zeros, you can still find the factors by finding the roots, x-intercepts, and the zeros. All right, so here use the discriminant b squared minus 4ac to see how many solutions there will be. All right, so right here, the discriminant b squared minus 4ac, we learned that if the discriminant is positive, so b squared minus 4ac is positive, that you're going to have two solutions. So when you graph this, it's going to cross your x-axis twice. And there's going to be two zeros, roots, or solutions. If your discriminant is 0, then you will have one solution. Okay, so again, remember the discriminant is this b squared minus 4ac. And if your discriminant is negative, you will have 0 real solutions. So your graph could look something like this, or like this. It would never cross the x-axis. So here's an example. Find the discriminant of 6x squared plus 7x minus 5. All right, so first up, find a, b, and c. A is the number in front of the x squared. B is the number in front of the x. And c is the number by itself. The discriminant is b squared minus 4ac. So we're going to plug in b squared is 7 minus 4 times 6 times negative 5. And you could just type that in. So we've practiced doing that in this unit. So we have 7 squared minus 4 times 6 times negative 5. And that discriminant is positive, 169. Since it's positive, there's going to be two real solutions. To find the solution, you plug into quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And so when we plug in, let's erase that. It's not going to let me erase. Okay, so when we plug in, it'll look like this. X equals opposite of b, so negative 7, plus or minus. And we plug in the b squared minus 4ac, which we did up here, so I'm just going to put this 169 here, all over 2a, and a was 6. So I said figure out those three numbers. I'll write it over here. X equals negative 7 plus or minus the square root of 169 over 12, and then split it up and type it in your calculator. So the first one was negative 7 plus the square root of 169. You hit enter. Divide by 12. And so we get 0.5. So I'll write that. And the other one is negative 7 minus the square root of 169. Hit enter. Divide by 12. Control enter. And we get negative 1.6 repeating. Let's move this over here. And so if we were to graph this, again, we have two solutions. One would be at 0.5, and one would be at negative 1.6 repeating. So our graph might look something like this. Okay, and then we did much more quadratic formula practice right here. So using the quadratic formula, let's do one more quadratic formula here. Let's start this. Solve for the following. So you saw the quadratic formula in the previous problem. Yeah, first up is you want to find a, b, and c. Actually, let's give ourselves more room here. Okay, so first step, find a, b, and c. So a will be 9. Here, we should put everything on one side. 9x squared plus 3x. You would subtract 12 from each side to get 0 on one side. We're looking for the zeros, so you do need that 0 on one side. So there's a is 9, b would be 3, and c would be negative 12. You plug into quadratic formula, which is up here. So I'd want to see that step x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. A is 9. And then I would want you to calculate these three numbers right here instead of typing everything all in your calculator, which sometimes gives you, room for mistakes there. So you have negative 3 plus or minus the square root. Let's type this in. So you have 3 squared minus 4 times 9 times negative 12, 441, all over 18. And then you split it up and you solve and you can find your two answers. So we get negative 3 plus the square root of 144, hit enter, divide by 18, so 0.5 again, x equals 0.5. And the other one will be negative 3 minus the square root of 441. Oh, I think I did that wrong. I did 144. Okay, so I'll have to redo that one. Negative 3 minus the square root of 144, hit enter, divided by 18. Okay, so one of our answers is negative 1.3 repeating, so that one's right. Let's redo this one. I typed it in wrong, so it should be negative 3 plus the square root of 441, hit enter, plus, okay, now divide by 18, so we should get 1. Okay, so that answer should have been 1, not 0.5. So here are the two zeros of the graph where they cross the x-axis. Also in that unit, we looked at using this to solve for word problems, so let's do that. Achille has an initial vertical velocity of 20 feet per second and release height of 6 feet when he's shooting a basketball. I should have put that. Write down the equation that represents the height of the ball over time if gravity has a downward acceleration of negative 16 feet per second. So here's his equation. His height over time will be that negative 16 x squared. That doesn't look very good. Let's fix that. So negative 16x squared plus 20x plus 6. Find the time when Achilles' ball reaches its highest point. So that's the vertex. So the time is x equals opposite b over 2a. So opposite b will be opposite 20 over 2a, 2 times negative 16. And then we can type that in, so negative 20 over negative 32. So negative 20 divided by negative 32. So at 0.625 seconds, his ball reaches its maximum height. Find the height of the ball at that time, you plug in. So we have y equals negative 16. We're going to plug in 0.625. We'll square that. Plus 20 times 0.625. Oops. Plus 6. So you can just type that in, negative 16 parentheses 0.625 squared plus 20 times 0.625 plus 6. Okay, so at 12.25 feet would be the maximum height of his ball. Okay, when will Achilles' ball reach a height of 10 feet? So we know that he tossed up that ball. So here's Achilles. Its max height here is at 12.25 feet. But at a certain point, it's going to reach 10 feet. And it's going to reach 10 feet twice. Like here, hopefully when it hits the basket and goes in, it'll hit 10 feet again. 10 feet the height of the ball. All right, so then we write our equation. Y equals negative 16 x squared plus 20x plus 6. But we want to know, when does this equal 10? And when does it equal 10? Well, we can use quadratic formula, but we need 0 on one side. So the next step is we'll subtract 10 from each side. So we have this equation, 0 equals negative 16x squared plus 20x minus 4. Now we have a new a, b, and c. So here, so you get 0 on one side, a is negative 16, b is 20, c is negative 4. Plug into what quadratic formula? X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Figure out your three different parts right here. So x equals negative 20 plus or minus the square root. Let's type that in, 20 squared minus 4 parentheses negative 16 parentheses, -4. So 144 all over 2a, so -32. Now we can split it up and solve. So first we'll do -20 minus the square root of 144. Hit enter. Divide by -32. That's correct. Okay, so we get 1. So first it hits at 1 second, and then it will hit the basket at the second one, -20 minus the square root of 144. Hit enter. Yep, divided by -32. Okay, so I did minus twice, it looks like. Let's do -32 plus. Oh, -20 plus the square root of 144 divided by -32. Okay, so 0.25 seconds was the first one. So at a quarter second, and then after 1 second, it will hit 10 feet. When would Achilles' ball reach the ground if he missed the hoop? So then we have this equation, -16x squared plus 20x plus 6. This is what you're going to use for A, B, and C now. So quadratic formula one more time, and then that would tell you when it would hit the ground. So again, here's his equation. So he has -16x squared plus 20x plus 6. Find A, B, and C. A is -16, B is 20, C is 6. X equals opposite B, plus or minus the square root of b squared minus 4ac all over 2a. Figure out your three numbers. I'm going to type in the discriminant. 20 squared minus 4, is that right? 20 squared minus 4 times -16 times 6. I guess that's 748. So 784. And then you split it up and solve. So again, you figure out these three things. Split it up and solve. Whoops. So we have -20 plus the square root. Oops. Let's redo that. So -20 plus the square root of 784. Hit enter. Divide by -32. So one is negative because if you think about him tossing up the ball, it goes up and then down. So here's that negative one. The other should be positive. So we'll do -20 minus the square root of 784. Hit enter. Divide by -32. So here will be the answer that we're looking for, about 1.5 seconds. All right. So there's a brief summary of quadratics for the final.